Good morning, class. We just knocked out two sections today, 2.1.2 and 2.2.1. 2.2.1 gets into the beginnings of calculus with sigma notation. It's going to start pretty basic. Today we're going to learn just a tool, how to write summation notation, and then we're going to kind of like expand this throughout the rest of chapter 2, and we'll end up getting really close to calculus. In your flip book at the top of 2.2.1, I'm going to give you some notes on sigma notation. Sigma is just a Greek letter, the Greek letter S actually, and what it represents summation. So we can think of this as summation. Also known as sigma, and summation obviously means to add, so we'll be adding a number of terms together. Now, I'm going to give you an example, and we're going to kind of break this apart. So let's say k equals 1, this is 3, and we call this k squared. We're going to break apart each component of this. So if we look at this number down here, this is called our lower limit. Or we can think of this as our first term. This top number, 3, this is our upper limit. Another way of thinking about this is our last term. And then the k squared, this is called our argument, which we've talked about in chapter 1, and this is what's going to function on those terms. So this is summation notation form, sigma notation. If we wanted to expand this out, this is what it would look like. We'd take our first term, which is 1, and we're going to 3, so we have a total of 3 terms, and we're going to use each k as our term number, and we'll substitute them in for k squared. So I'm going to write it out like this: blank squared plus blank squared plus blank squared. So our argument, since it's k squared, we'll be substituting in our k. We're starting at 1, we end at 3, and we're just going to go up by whole numbers because our term numbers can never be decimals or negative. So if we go ahead and add all of these up, you'll get a total of 14. The sum for this sigma will be 14. Let's look at an example where we kind of explore this a little bit further. Alright, so let's take the example. We're going to evaluate the sum, and we're going to change the upper and lower limit a little bit. Make the lower limit 2 and the upper limit 5, and our argument's going to be different too. Your argument will actually usually change, as well as your upper and lower limit. It's more understanding how to read this. So if we think about this, we're going to need to write this in expanded form. You're starting at term number 2, you're going up to 5. Most students think there's only 3 terms. There's actually 4. Your second, your third, your fourth, and your fifth. So kind of like I did previously, I'm going to use parentheses as kind of my placeholder for the input. So first term, second term, actually second, third, fourth, and my fifth term. And the reason I'm lining it up like this, it will be easier to add. It provides a little structure. So 2 is our second term, 3, 4, and 5. And now we can go ahead and add each one of these together, and then we'll add the whole sum. So you get 7, 10, 13, and 16 for a total sum of, I think it is 46. Yep. Alright, the last example we'll look at, part B, you can write this right next to it if you still have space. M equals 1, going up to 4, 1 over m times m plus 1. Again, lay it out in terms of how many terms you have. We're going from 1 to 4, so we're going to have 4. And notice you have now 2 m's, which means you're going to substitute in your input twice. So 1 over, I'll use parentheses, blank times blank plus 1. That'll be our first term, and we'll do this 4 times. I got a new stylus, so it's not clicking as much as the old one was. I don't know if that's better on your ears. Let's see. Alright, so we're starting with our lower limit of 1. So 1, move to 2, move to 3, and then move to 4.